Hey guys, sorry about that. I know I was right in the middle. I didn't realize I was quite to that 15-minute mark yet. So where I left off was saying how taking the 82 and 4/10 and dividing it by the 1200ths of a dollar, when we divide that, it's going to be this big long decimal. And I mean, it's 600. Oops, why didn't that write? 683.6 repeating. So we could say that it's at about 684 kilowatt per hour. So you can round that up, obviously, since we're looking at how many kilowatt hours they used. It's an acceptable thing to round there because it's not necessarily saying the exact amount. It's also not saying you have to round it, but I would accept either on a question like this if you were doing it, okay? All right, so those are a few times in which we're taking and doing rational numbers. So remember, a rational number is both positive and negative. It can be a whole number, it can be a decimal, so long as it's a finite decimal, or it's like this 683.6 here. This 0.6 repeating, that is a rational number because we could rewrite that as 2/3. So any decimal that we can write as a fraction is a rational number. So that's what rational numbers really are here. So we're looking at subtraction and division, and we saw some multiplication earlier and addition. So using all four of those operations to really work through and solve problems. All right, so we're going to look at lesson 15 now. So for lesson 15, first thing we want to do is match each equation to its solution and explain our reasoning. So for A, we have 1/2 x equals -5. Now, what would we have to take and do to solve for this x value? We'd need to multiply by the reciprocal. So reciprocal is your keyword for this lesson. So the reciprocal of 1/2, so 1/2, the reciprocal equals 2/1. So it's just flipping the fraction. So we've looked at flipping the fraction and talking about reciprocals before. So if we multiply both sides of this by the 2/1 times 2/1, that cancels out the 1/2. So we're just left with x, and then equals -5 times 2. Well, -5 times 2 is -10. So this one is 3. So I'm just going to put the number of the solution in a box over here by it rather than drawing lines, because obviously drawing lines and trying to match, it gets confusing to figure out, okay, what line does that actually go to? All right, for the next one, we have b equals -2x, or sorry, b is -2x equals -9. How would we get the -2 away from the x? So if these two things are being multiplied, to undo multiplication, we use division. So we divide both sides by 2. And if we divide -9 by 2, we have -2. If we divide -9 by -2, two negatives make a positive, and half of 9 is 4.5. Next one, we have -1/2 x equals 1/4. So in this case, the 1/2 is being multiplied to the x. Being as we're dealing with a fraction, though, we can use reciprocals. So we can multiply by -2/1 to both sides. If we take and multiply, it's supposed to be a negative. There we go. If we multiply 1/4 to -2, we're going to end up with -2/4, which is the same thing as a -1/2. All right, the next one here, we have -2x equals 7. So once again, these two numbers are being multiplied together. So to undo them, we need to take and divide. So dividing by 2, or multiplying by 1/2, since we know 2 and 1/2 are reciprocals of each other. And so when That should be a -2, sorry. And when we divide 7 by -2, we end up with -3.5. So that's 4, 6. All right, for E, x plus -2 equals -6.5. Now be careful here. We have the operation of adding, but our value is negative. So you have to be super careful with that. A lot of times, if we saw this on an assignment, I would say to rewrite it so there's only one sign in between your x and your 2. So I'm going to rewrite E. E is x minus 2 equals -6.5. So anytime we're adding a negative number, we can rewrite it to say x minus that number. So that makes it a little easier to think about doing the opposite. So if we do the opposite of subtraction, that would be addition. So we'd add 2 to both sides. So we end up with x equals, well, -6 plus 2. So we're at -6, but now we're going 2 closer to the positive side. So we end up with -4.5. So that would be for 1. So E is 1. Just squeeze that 1 in right next to it. And the last one, we have -2 plus x equals 1/2. So once again, in this case, we have a -2 is being added to x. But we need to move this over to this side. So in order to cancel out the -2 here, what do we have to add to -2 to get 0? Well, we have to add +2. So we're going to add 2 to both sides. So x equals a +2.5, which would be 5. So there's our matching there. So we really looked at additive inverses and reciprocals. So reciprocal is your key word for this lesson. Keep that in mind. All right. Next thing we're looking at, a trip to the mountains. The hiking club is on a trip to hike up a mountain. The members increased their elevation 290 feet during their hike this morning. Now they are at an elevation of 450 feet. Explain how to find their elevation before the hike. So I actually have this wrote out to make it a little easier so you don't have to watch me write and don't have to try and read what I wrote all over the screen. So if we're explaining how we found their elevation, how we would find their elevation would be to subtract the change of 290 from the current elevation of 450. So we'd subtract that change to see what their new elevation was. So then for part B, I know you're seeing B and C on here as well. For B, it says, Hans says the equation E plus 290 equals 450. Describes the situation. What does the variable E represent? Well, E represents the starting elevation because it's telling us the members increased their elevation 290 to be at an elevation of 450. So we don't actually know where they started off. They could have started off at 280 for all we knew. And then, or not 280. They could have started anywhere and added that 290 to get to the final elevation of 450. It didn't necessarily have to be that exact placement. They didn't start at 0 because they didn't end up at 290. It was just that's the change that they had. All right, and for C, Hans says he can rewrite his equation as E equals 450 plus -290 to solve for E. Compare Han's strategy to your strategy for finding the beginning elevation. So Han used a variable to represent the unknown quantity. He wrote an equation to describe the situation and then solved by adding the opposite. So what we looked at was simply just, okay, we know where they ended up. We know how far they went. Subtract those two. That's going to get us our actual starting elevation. So the 450 minus 290, which gets us the 160. So giving us that final elevation. What Han did, though, is he wrote an equation that represented the situation. So some value plus this amount of change equals this final elevation. And then he solved it using what we did previously. So looking at the additive inverse. So adding the opposite to both sides to cancel out. All right, for number 2. Oops. The temperature fell 4 degrees in the last hour. Now it's 21 degrees. Write and solve an equation to find the temperature it was an hour ago. So our equation, it tells us that the temperature fell 4 degrees in the last hour. So we had some temperature that we started off with, T. We subtract 4 because it fell that much, and now it's 21 degrees. So T minus 4 equals 21. To solve for it, we would take and add the opposite to both sides. So the opposite of subtracting 4 is adding 4. So we add 4 to both sides. So the 4's here cancel out. So we're left with T equals 21 plus 4, which is 25. So it started out at 25 degrees. So this is using the method Han did, writing an equation to be able to take and solve. It's good to be able to write equations based on a situation. You'll use more of that later on in math as we continue to go. You're going to be expected to figure out how to write an equation based on the situation. All right. Number 3, there are 3 times as many students participating in the hiking trip this year than last year. There are 42 students on the trip this year. Explain how to find the number of students that came on the hiking trip last year. So for this one, divide this year's number by 3, since it said there's 3 times as many students participating, or multiply by 1/3. Remember, we can always use reciprocals. So instead of dividing, we can always just multiply, and worrying about multiplying with fractions. So that's how we can take and find this new value. Now, for B, which is just down below, my says the equation 3s equals 42 describes the situation. What does the variable s represent? So s represents the students from last year's trip because it's 3 times as many as last year's trip to get to this 42. So that's how we know that the S represents the students from last year's trip. All right, our next one here. Let's see if I can make it scroll. Okay, Mai says she can rewrite her equation as S equals 1/3 times 42 to solve for S. Compare Mai's strategy to our strategy. Well, Mai used a variable to represent the unknown quantity and wrote an equation to describe the situation, then solved by multiplying by the reciprocal. Now, in ours, we talked about multiplying by the reciprocal. Let me hold that there for a little longer for you. We talked about multiplying by the reciprocal, multiplying by the 1/3, or dividing by 1/3, multiplying by 3, using the different ways to represent it. Sorry, multiplying by 3, yeah. So multiplying by the reciprocal is always a way to take our total and then figure out how many there were to start with. So multiplying by the 1/3 or dividing by 3. They represent the exact same thing because they're reciprocals of each other. So, and it's using opposite operations for it as well. So just be careful with your operations when you're doing that. Okay? All right. Remember, your keyword for this lesson is reciprocal. If you have any questions or get stuck on anything, feel free to let me know. Have a great day, you guys. Bye.